Probability can be a daunting unit for the Algebra 2 student. However, this video will go over the basics of probability and also solve some examples. To start off, I'll give you all the probability equations that you'll need. First is the complementary events formula. Complementary events are events that can only happen. For example, there is a bag full of red marbles and blue marbles. The complementary events would be pulling out a red marble or pulling out a blue marble. There is no possibility of pulling out a yellow or green or purple marble because your only choice is either a blue or red marble. The equation is the probability of A plus the probability of not A equals 1. Next is the combined events equation. Combined events are events that have overlap. For example, a student can either take music class or technology class. The combined event would be a student taking both music and technology. The combined events formula is the probability of A or B equals the probability of A plus the probability of B minus the probability of A and B. Also, it's important to note that combined events cannot be mutually exclusive. Mutually exclusive events are events that cannot have overlap. For example, when you flip a coin, you either get heads or tails. You can't get both heads and tails in one flip, therefore these events are mutually exclusive. The mutually exclusive formula is the probability of A or B equals the probability of A plus the probability of B. There's also the conditional probability formula. Conditional events are events that happen only when another event has occurred. For example, take the bag of red marbles and blue marbles. The probability that you pull out a red marble, given that you pull out a blue marble first, is conditional. The key word to this equation is the word given. The equation is the probability of A and B equals the probability of A times the probability of B given A. The last probability formula is the independent events formula. During independent events, one event does not have an effect on another event. For example, each time you flip a coin, you have an equal chance of getting either heads or tails each time. Getting 20 heads in a row, for example, does not mean you'll get a tail the next time you flip it. Therefore, this event is independent. The independent formula is the probability of A and B equals the probability of A times the probability of B. Now let's solve some problems with this new information. Here's the information for the first problem. The probability of rain on Monday is 30% and on Thursday is 40%. Assuming these are independent, find the following probabilities: that it rains on both days and that it doesn't rain on either day. To find the probability that it rains on both days, we have to use the independent events formula. Input your values and we should get 0.12 or 12%. We use the independent formula because we were trying to find the probability that it rained on Monday and Thursday as seen in the equation. To find the probability that it doesn't rain on either day, we subtract 0.3 from 1 and we subtract 0.4 from 1. This gives us the probability that it doesn't rain on either given day. We end up with 0.7 and 0.6. Now we use the independent formula events again, only with the inverse of these probabilities. 0.7 times 0.6 is 0.42, so your answer is 0.42 or 42%. Now here's the information for the second problem. Suppose a box contains 3 defective light bulbs and 12 good light bulbs. 2 bulbs are chosen from the box without replacement. Find the probability that one of 2 bulbs drawn is a defective and one is not. The first thing we have to notice is that the question states without replacement. This means the bulb is not put back in the box. Therefore, our denominator goes down with each successive light bulb that is pulled from the box. For example, the probability of getting a defective light bulb is 3 out of 15 because there are 3 defective light bulbs and 15 total light bulbs. Then you draw a good bulb. However, you have already drawn a bulb, a defective one from the box, so you only have 14 bulbs to draw from. Therefore, your chances of drawing a good bulb after you draw a defective one is 12 out of 14, because there are 12 good bulbs and 14 total bulbs. 3 out of 15 times 12 out of 14 equals 6 out of 35. We add 6 out of 35 to itself because we are drawing 2 bulbs, and the final answer is 12 out of 35. Well, I hope you learned something from this lesson on probability. Remember, The equations will be given you on the IB exam, so there's no need to memorize them. Good luck!